Yeah, so I'm René from NeoCarbon, and we upgrade industries to negative emissions. So, like you all know, humanity is emitting way too much CO2, and we dramatically need to cut emissions. But unfortunately, that's not enough anymore. We actually need to remove 6 to 10 gigatons of CO2 per year by the mid of the century, so massive amounts. When you look at the different technologies that can actually create this massive amount of negative emissions, you quite soon realize that a lot of them have limitations. And only one is not limited by the land use and by the biomass, which is direct air capture. But here the problem is very, very high energy use, like energy intense, which leads to very, very high prices. But let me explain you why it's so expensive. So when you look at the technology, it's like a big artificial tree, I would say, 100 times more efficient than a normal tree. You could not plant all the trees in the world to basically remove this large amount of emissions that we need to remove out. So what are the steps? So first, you basically blow air through your unit in your box, which is like a container. You have a non-toxic chemical. CO2 gets attached to it. Nitrogen, oxygen just flows through your unit. In the second step, you close your box. You have a certain pressure in it, and you heat it up to 95 degrees Celsius. And then you release the CO2 as a pure stream. You have it as a gas, 99% purity. This CO2 you can either utilize, for example, for sustainable aviation fuels, or, of course, you can store it underground geologically for thousands of years. This process you can run over and over again. When you look at the technology, you see that, especially on the OPEX side, the heat is the main cost driver, and a lot of the direct air capture processes are not really reliable. So with that, they can't really scale to the massive amounts because, they are just limited in the reliability of their tech. So we had a deep look into this and came up with a new reactor design, which is not limited, or which limits basically the movement of the reactor. So it's a packed bed approach, which is 50% more energy efficient than the state-of-the-art for direct air capture, and 10 times more robust, so way more reliable system because you don't have all those moving parts. We have the first patent actually already on this. So we have been innovative in how to do direct air capture. And in the second step, we have been innovative where to do direct air capture. So still, the energy demand stays high because of thermodynamics. So we look, where can we find the best spot to deploy direct air capture? And the best thing is to use already existing industrial sites. To, on the one hand, capture from the flue gas, and then use the waste heat from that process to fuel our direct air capture plant. So for a typical cement plant, for example, they would normally emit, for Germany, roughly 1 million tons per year. You would capture 800,000 tons from the flue gas, so 80% efficiency. And then on top of it, with the waste heat from the process, you could capture additional 350,000 tons from ambient air. So the overall cement plant would capture more CO2 than it would normally emit, and that's then this negative emissions. And that can scale very, very big. So 350,000 tons with one cement plant only in Germany would be 10 times bigger than the global market of direct air capture right now. And to summarize on NeoCarbon, so we have a patented reactor technology with an external tech validation from Fraunhofer, IPT, so we are very sure that we can also scale up. We are financed by 4 VCs already with 4.5 million and got additional 1.5 million in grants. We have more than 1,000 operating hours, so one unit is already running since a year here in Berlin. And we just shipped a first unit to a paid customer to the west of Germany, a big Japanese industrial that actually bought it, but with global operations, which you can see here, the Neo Duo. And at the end product, we have then the mineralized CO2. And we just signed already the next customer. So right now we have more than 500,000 of revenue already. And in the next step, we are looking for more pilot partners. So very interesting for us, of course, are energy companies that can open doors to a lot of different industries. But of course, cement plants, chemical parks are very, very relevant. And we are looking for further funding in early 2025, ideally for a 10 million round Series A led by a strategic investor, which is also the expertise to scale our technology together with us. Thank you.